This video is on slope and rate of change. We have seen the formulas of slope, which is change in y over change in x, or delta y over delta x, or rise over run, y2 minus y1 over x2 minus x1. We've seen how to find the slope from two coordinates by just plugging them into the correct y's and x's. And now what we're going to do is find the slope from a table. So we still have to use those same formulas. We just have a table. So I'm going to write out the formula of delta y over delta x. So I want to know the change in y and then the change in x. So I'm going to look at my x values, this is in a table, it's going horizontal table. How are my x values changing from step to step? So from 0 to 3, I am increasing by 3, I'm adding 3. From 3 to 6, I am also adding 3. From 6 to 9, I am also adding 3. Then I also want to see how my y values are changing. So from 20 to 11, I'm subtracting 9. From 11 to 2, I am subtracting 9. And from 2 to negative 7, I am subtracting 9. So 20 minus 9 gives me 11. 11 minus 9 gives me 2. 2 minus 9 gives me negative 7. Now, since all of these are the exact same, that helps us, because there's no difference in the numbers that we have here. But we can always look at it as delta y over delta x. So the y's for this set right here, this is negative 9 over, because that is a delta y, over the change in x was that positive 3. This set would be the change in y is negative 9 divided by the change in x is positive 3. And then we also have this set of change in y is negative 9 over the change in x is positive 3. Negative 9 divided by 3, negative 9 divided by 3, negative 9 divided by 3. All of these are the same, so we have negative 9 divided by a positive 3 is equal to a negative 3. So our slope is negative 3. Our rate of change is negative 3. On this next example, we have x and g of x. Now in previous videos, when we're talking about key features of a function, g of x means the same thing as y. It means it is a function of x. So again, we want to find that delta y over delta x. So we need to find our changes. So for our x's, if we just start on the top, from 6 to 5 is subtracting 1. From 5 to 7 is adding 2. And then from 7 to negative 3 is subtracting 10. So these are all different, but we want to see, is the rate of change constant once we simplify everything? So on our y's, from 5 to 5 is adding 0, or subtracting 0, whichever. From 5 to 5 is also adding 0. From 5 to 5 is also adding 0. So if we were to rewrite these like I did on the first one, change in y on this first set is 0 over change in x is negative 1. Change in y is 0 over positive 2. The last set is change in y is 0 over the change in x is negative 10. 0 divided by negative 1, 0 divided by 2, 0 divided by negative 10 is all equal to 0. They all are the same, so therefore our slope is 0. We have a horizontal line, we have a 0 slope. On this next one, we want to look at the change in x and the change in y. So f of x, again, is the same thing as saying y. This one is a vertical table, but we do the same thing. So if I look at my x's, from 0 to 2 is adding 2. From 2 to 8 is adding 6. From 8 to 12 is adding 4. Then I look at my y's. From 3 to 6, I'm adding 3. From 6 to 15, I'm adding 9. And then from 15 to 21, I'm adding 6. So I actually do the same thing as I did on this one and on the one before. I have 3 sets of changes, and I look at the fractions for all of those. So my change in y for this first set is 3, positive 3, over change in x is a positive 2. So I have 3 over 2. My next set is change in y is a positive 9 over change of x is a positive 6. And my last set is a change in y is a positive 6 divided by the change in x is a positive 4. If I were to simplify these, so 3 over 2 stays as 3 over 2, that is as simplified as it gets without turning it into a decimal. 9 over 6 will simplify down to 3 over 2, and 6 over 4 will simplify down to 3 over 2. Since all three of these have the same value, so it is constant, our slope, or our rate of change, is equal to 3 over 2. This is how we find the slope from a table. You find the change in x on each of them and all the changes in y's, and make sure that each set, as you find them, remain the same throughout the entire table.